Assalamu alaikum wa rahmatullahi wa barakatuh. BSM2 analysis of specific absorption rate of brain stroke using UWB antenna and the human head phantom. My name is Khalid Adel and my supervisor is Dr. Azhari bin Saleh. And the brain stroke is the main cause of adult disability worldwide. A stroke happens when a blood artery bursts, disrupting the blood flow to a portion of the brain. A common nerve-filled UWB antenna is purposed for use as sensor and a study to detect brain stroke type and the microwave system. And the antenna is printed on regular 4350B substrate. The goal of this study is to investigate the SAR value of a brain stroke and the director of a brain stroke using a head modeling. CST software will be used for all antenna design and head modeling. This study will compare the coefficient result of brain stroke and head phantom modeling with or without tumor. What exactly to develop a system or solution that can detect the type of brain stroke utilizing UWB antenna, analyzes the qualities and parameter of the brain stroke head phantom, give a good sustainability impact because low cost and an alternative method for microwave and CT scan because can be used in ambulance and unwritten world. Problem existing imaging technique for brain stroke identification such as microwave and CT scan have limitation. For instance, high cost, large size, safety, crown, and inability to transport. The type of brain stroke allows the microwave approach as an alternative and a combiner with antenna as a sensor. This technique can outperform microwave and CT scan in terms and acuteness. The following goals are considered in order to create the system: to design and simulate the UWB antenna for brain stroke detection. Also, the second one is to analysis of SAR and the head phantom. The project begins with the development of a microwave system for brain stroke detection that use a UWB antenna level simulation of UWB antenna using CST software, head phantom modeling based on directoric properties, its parameter SAR value, Jan, and radiation pattern are among the parameters examined. Compare head phantom with and without brain stroke. And this is my project impact. of the lesion and normal issue, which is principle of deduction. Microwave imaging for biomedical applications is gaining a lot of traction these days, with the ability to reveal both physiologic states and anatomical structures of human tissue. The coplanar beveled antenna two radiator planes are on the same side of the detector materials. The antenna can be fed by a pressure coplanar from the other side as debacked and optimized using genetic algorithm and the CST software. For the advantage of coplanar beveled antenna, their wide-ranging properties suitable for ultra-wideband signals. The simple manufacturing approach using conventional PCB fabrication method, employing microstrip line modeling approach for easy impedance matching to the feeding line. The coplanar beveled antenna is proposed to solve the feeding and coplanar ones. This antenna can be fed easily by soldering the connector to the two sides of the PCB material. As you can see here, this is my result before and after. This is analysis of this type of antenna substrate for ministrate UWB antenna, beveled antenna. The visibility of the concept proposed antenna is checked using the CST microwave studio through simulation. Figure 11 showed that the UWB beveled antenna using Roger RUR 4305B substrate operates from 1.25 GHz to 3.75 GHz with a return loss of minus 31.684 dB, and the bandwidth arising from the S11 parameter is 775.5 MHz, while for the UWB beveled antenna using FR4 substrate is measured, it can be shown that the return loss over the 1 GHz to 4 GHz band is minus 13.522 dB, and the antenna provides a better response and the parameter after change the antenna substrate. The bandwidth result from the S11 parameter is 1.8 GHz. Overall, the UWB antenna beveled antenna using FR4 substrate has a higher gain and directivity than the UWB beveled antenna using Roger RO4305B substrate. This is an 100 mm, as you can see here, spherical head with a uniform surface. The model is a 5-layered spherical head, the 5 type of tissue, and this is modeling. Our skin is 1 milli, as you can see here, millimeter. Fat is 0.5 millimeter. Muscles is 2 millimeter. Skull is 5 millimeter. And now this is the advanced modeling. As you can see the expression here. And this is the description of project. This project is expecting to produce a system or solution which can detect the brain stroke type by using UWB antenna. UWB coupler beveled antenna will be designed and had modeling for the brain stroke detection, classification, analysis of brain stroke. As you can see here for figure 1 and figure 2 and the figure 3, the table about the skin, the tissue, the color, and every details. Project progress. This simulation 3D radiation pattern integrate the directional radiation as shown in the figure 1 as shown in the figure. The maximum gain of the proposed coupler beveled antenna can reach 2.04 dB at 2.1 GHz. It can be seen the maximal radiation is along central axis of the covered slot. For the conclusion, the function and characteristic of the UWB coupler beveled antenna and had modeling simulation for brain imaging were explored and the conclusion of this paper. As a result, a coupler beveled antenna with a simple design has been proposed. The proposed antenna structure function as a wide spectrum from 1 to 4 GHz and has a high flat gain, and the goal of this search was to create a low-cost, simple, flexible, smart microwave head imaging for brain stroke detection. Design the UWB beveled antenna for brain imaging and test the antenna capacity to detect a brain stroke within a head phantom using CST software. And this study proposes technique detection of strokes. This project has the potential to be a game changer the healthcare business. It can be used properly without recording expensive equipment. This most hospital may use it to patents, particularly for recording disorders like brain stroke. And this is my reference, and thank you so much for listening.